Hi. Welcome to J6 Chemistry channel. Please don't forget to like and subscribe. Today we will discuss about atoms, molecules, Dalton's atomic theory, and related theories on the nature of atoms. So what is an atom? An atom is the smallest indivisible particle in a chemical element. It is also the smallest unit of ordinary matter that forms a chemical element. Every solid, liquid, gas, and plasma is composed of neutral or ionized atoms. An example would be a carbon atom, hydrogen, oxygen, or nitrogen atom present in a human body. On the contrary, what is a molecule? A molecule is a combination of two or more atoms that has its own characteristic set of properties. Specifically, these are neutral group of two or more atoms held together by chemical bonds. Examples of a molecule would be water, glucose, caffeine, or even DNA. What is an ion? An ion can be an atom or molecule with a net electric charge due to the loss or gain of one or more electrons. In that case, the number of electrons is not equal to the number of protons. When a stable atom gains or loses an electron, it becomes an ion. Examples of these processes include the reaction of a sodium atom with a chlorine atom to form a sodium cation and a chloride anion, the addition of a hydrogen cation to an ammonium molecule to form an ammonium cation, and the dissociation of a water molecule to form a hydrogen cation and a hydroxide anion. In 1808, an English scientist and school teacher, John Dalton, formulated a precise definition of the indivisible building blocks of matter that we call atoms. The hypotheses about the nature of matter on which Dalton's atomic theory is based can be summarized onto four postulates. Postulate 1: an element is composed of tiny particles called atoms. Postulate 2: atoms of different elements have different properties. An element is a type of matter composed of only one kind of atom, each atom of a given kind having the same properties. Mass is one such property. Thus, the atoms of a given element have a characteristic mass. Postulate 3: compounds are formed when atoms of two or more elements combine. In a given compound, the relative number of atoms of each kind are definite and constant. Compounds are formed when atoms of two or more elements combine. Water, for example, a compound of the elements hydrogen and oxygen, consists of hydrogen and oxygen atoms in the ratio of 2:1. This idea is an extension of a law published in 1799 by Joseph Proust, a French chemist. Proust's law of definite proportions states that a given chemical compound always contains its component elements in fixed ratio by mass and does not depend on its source and method of preparation. Thus, if we were to analyze samples of carbon dioxide gas obtained from different sources, we would find in each sample the same ratio by mass of carbon to oxygen. Dalton's third hypothesis supports another important law, the law of multiple proportions. According to the law, if two elements can combine to form more than one compound, the masses of one element that combine with a fixed mass of the other element are in ratios of small whole numbers. For example, carbon forms two stable compounds with oxygen, namely, carbon monoxide and carbon dioxide. The ratio of oxygen in carbon monoxide to oxygen in carbon dioxide is 1:2. Postulate 4: in an ordinary chemical reaction, No atom of any element disappears or is changed into an atom of another element. Chemical reactions involve changing the way in which the atoms are joined together. The fourth postulate is another representation of law of conservation of mass. The law states that the mass of an object or collection of objects never changes, no matter how the constituent parts rearrange themselves. An example given below is the combustion reaction of methane, where 4 atoms of hydrogen, 4 atoms of oxygen and 1 of carbon are present before and after the reaction. The total mass after the reaction is the same as before the reaction. Thank you very much for listening. Please don't forget to like and subscribe on J6 Chemistry channel. Always keep safe.